Today we're going to go over the 2A review worksheet. So this is just a worksheet. It's going over all the questions from Algebra 2A. Numbers 1 through 4 are going to be using this hint page. So if there's no parentheses, you're going to be using standard form, so it's A, B, and C. If it's got two sets of parentheses, you can use the intercept form, that's A, B, and Q. One set of parentheses, you're going to be using vertex form, that's A, H, and K. Alright, so we're going to go over number 1. So number 1 is y equals negative x squared plus 6x minus 8. So once again, there is no parentheses. So you're going to use standard form steps. So you're going to find A, B, and C. A is negative 1. That's the number in front of the x squared. B is 6. C is negative 8. Now I use the vertex formula. I get x equals the opposite of B all over 2A. Put the bottom in parentheses in case I'm going to plug in on my calculator. So I have negative 6 all over 2 times negative 1, which means I have negative 6 all over negative 2, which means negative 3. That's the middle of my xy chart. So I make my xy chart, but it's supposed to be positive 3. I put positive 3 in the middle. I add 1, add another 1, I subtract 1, I subtract another 1. Now I don't do much work. I have to plug in 1, and that's going to rainbow over to give me 5, and I have to plug in 2. It's going to give me 4, and then I'll plug in 3. So I'm actually only going to plug in 3 points. I plug in 1, so I have negative, in parentheses, 1 squared, plus 6 times 1 minus 8. So I get negative 1 plus 6, it's negative 5, it's 5. Minus 8, it's going to be negative 3. So now I know 5 is negative 3. Now I'm plugging 2, so I get negative, and then 2 squared, plus 6 times 2 minus 8. So I get negative 4 plus 12. It's positive 8 minus 8 is going to be 0, which means 4 is going to be 0. Now I plug in 3, so I get negative in parentheses 3 squared plus 6 times 3 minus 8. So I get negative 9 plus 18, which is positive 9, minus 8, which is going to be positive 1. And I plot my points. I go over 3, up 1, put a dot. Because that's the vertex, it's going to be a dotted line here. That's not part of my graph. That just tells me that it's the center of my U. I go over 2, put a dot. I go over 4, put a dot. I don't go up and down because the y is equal to 0. And I go over 1, go down 3. And I go over 5, down 3. It is symmetrical, so I connect my dots to make it a nice smooth U. I make sure my arrows go down, and that's it, done. 2 is the exact same concept. So I say A is 1, B is negative 2, C is negative 1. Say the x equals the opposite of B, so it's positive 2, all over 2 times 1. So I get 2 over 2, which is going to be 1. Make my xy chart. Put 1 in the middle, I add 1, I add 1, I subtract 1, I subtract 1. I always do 0 if I can because 0 is really easy. It's like going to spit out negative 1. It's going to rainbow over to give me 2. Now I'm going to plug in 1 because it's the middle. So I plug in 1, I get 1 squared minus 2 times 1 minus 1, I get 1 minus 2, which is negative 1, minus another 1, it's going to be negative 2. Now I'm going to plug in negative 1. So I get negative 1 squared, which is positive 1, minus 2 times negative 1, minus 1, so I get 1 plus 2, which is going to be 3, minus 1 is going to be 2. And I rainbow that over so I don't have to plug in 3. So I go 1, negative 2, put a dot. Here's my dotted line. 0, negative 1, put a dot. 2, negative 1, put a dot. 3, up to 2, put a dot. Negative 1 up to 2, put a dot. Alright, and that's it. And I knew it should have been a U because A is positive, so that's pretty easy. Alright, so number 3 is intercept form because it's got 2 sets of parentheses. So I'm going to say A is 2, P is negative 3. Remember, we don't trust anybody hanging out in the parentheses with our X. And Q is positive 1. So once I have A, P, and Q, the next step is to find the vertex formula, which is P plus Q in parentheses all over 2. So in parentheses, say negative 3 plus 1 all over 2. We get negative 2 all over 2, which is negative 1. So when I make my XY chart, I have negative 3, then I put negative 1, and then I put 1. If you want to add some points in between to make it 5, you can, but you don't need to. So I don't even plug in negative 3 or 1. I automatically know those are 0 because it's the rule by intercept form. So I say 2 parentheses negative 1 plus 3 parentheses negative 1 minus 1. So I get 2 times positive 2 times negative 2. I end up with negative 8. So I graph my points. I go left 1 down to 8. Remember, that's my vertex. So there's an axis of symmetry going through there. I go left 3, 0. Right 1, 0. I'm going to make that a nice smooth curve. And there we go. That's it. That's it. Done. Alright, number 4. This one's intercept form, so I have H and K. So A is negative 2, which means it's a frowny face. H is going to be positive 1 because we don't trust anybody hanging out with their X. K is 5. Because it's vertex form, all I need is the vertex to start, 1, 5. I'm going to add 1 to get 2. I'm going to add 1 to get 3. I just plug them in. So here I have 2. 2 minus 1 squared plus 5. 2 minus 1 is 1. 1 squared is 1, so it's negative 2 plus 5, which is going to give me negative a positive 3. I'm plugging 3. Negative 2. 3 minus 1 squared plus 5. I get 2 squared, which is 4 times negative 2 is negative 8. Plus 5, it is going to give me negative 3. So I go over 1 up to 5, put a dot, and that's my dotted line. And for this one, you really need that dotted line, because I only did 3 points in my XY chart. I go over 2, up 3, put a dot. I'm going to reflect that over to get the other dot. I'm going to reflect it over the dotted line to get the other dot. I'm going to go over 3, down 3, reflect it over to get another dot. And that's it. Done. For numbers 5 through 10, we'll be using the GPS. So we've done that before. So this is the hint page we're going to use for that. Alright, number 5, we have n squared minus 3n plus 9. So remember, it's got 3 terms, so I take the factors of the first term, n and n. Factors of the last term, 1 and 9, or 3 and 3. Now, because the number in front of the n squared is 1, you can use the adding shortcut. So if the middle was 10, I would use 1 and 9, which it's not, so I can't. If the middle was 6, I use 3 and 3, which it's not. So since none of those work and there are no other factors, this one's actually not factorable. That's it. 6. We have x squared minus 49. So there are 2 terms, which means I hope that they are perfect squares with a subtraction sign. X and x is perfect. 49, 7 and 7. Since they're perfect and there's a subtraction sign, I know my factored form is going to be x plus 7, x minus 7. Because remember, factoring is bringing the parentheses and putting them back in. So that's it for 6. Alright, number 7, we have x squared minus 5x plus 36 equals 0. Remember, when you solve it, it must equal 0. So before I do anything, it must equal 0, and that means I can factor it. So how do I get x squared? X and x. How do I get 36? 1 and 36 doesn't help me. And this should be minus 36, which means one of those is negative. Negative 2 and 18 doesn't help me. Negative 3 and 12. So the reason negative 1 and 36 doesn't help me, it adds up to 35. Negative 2 and 18 adds up to 16. Negative 3 and 2 adds up to 9. Negative 9, or negative 4 and 9. That one's going to work. So I say x minus 9, x plus 4. Remember, it equals 0. Since it equals 0, I get to say x minus 9 equals 0. And x plus 4 equals 0. I add 9 to both sides, I get x equals 9. I subtract 4 from both sides, I get x equals negative 4. So those are my 2 answers. Here's my factored form. Here are my 2 answers. That's it for 7. Alright, so number 8, you have 4u squared plus 12u plus 5. So remember, the first thing you do in 3 terms is you look for something in common. There is nothing in common, so then I just do the factors of the first term. I could have 1u and 4u. I could have 2u and 2u. Now would I check 5? 1 to 5 is my only choice. Now I can guess either one of these, either 1u and 4u or 2u and 2u for my first set of parentheses. I'm just going to guess 2u and 2u. And there's not really a reason for that, except just in my experience, it seems to work out more. Now I'm guessing these. I don't know if this works. Because remember, 1 to 5 has to be 6. That doesn't matter anymore, because the adding shortcut only works if the squared term is 1 as a coefficient. So do the outside to get 10u. Do the inside to get 2u. Together that's 12u. That's exactly what I want. So that is your factor form right there. 2u plus 1, 2u plus 5. Alright, number 9, we have negative 16n squared plus 12n. It's two terms, but you should not be looking for first rows yet because they have letters in common and numbers that go into both of those. So 4 is the biggest number that goes into both of them, and they both have at least one n. Now personally, I don't like that first term being negative, so I always, if it's negative, I put the negative outside the parentheses. You don't have to do that. Negative 16 over negative 4 is positive 4. I had two n's, I took one out, I'm left with 4n. 12 over negative 4 is minus 3. I have one n. I took it out, so I don't have to put it out there, and that's it. Ten. I have 12x squared plus 7x plus 2 equals x plus 8. Remember, in order to solve, it must equal 0. So if you're going to solve by factoring, you have to make it equal 0. So the first thing I do is subtract x from both sides, and I subtract minus 8 from both sides. Subtract 8 from both sides. So I end up with 12x squared plus 6x minus 6 equals 0. Personally, I noticed that all three of them are divisible by 6. So I'm going to take the 6 outside the parentheses to make my life much easier. 2x squared plus 2x minus 1. Now I'm breaking down the factors of the first term. How do I get 2x squared, 2x and x? How do I get 1, 1 and negative 1? So now I just have to figure out which one goes with which. And I have a 6, 2x plus 1, x minus 1 equals 0. I do the outside to get minus 2x, and the inside to get 1x. Together it's negative 1x. It's not what I want. It's also not the opposite sign, and there are no other choices. So that means 10 is going to be not factorable. And that is it. So, numbers 11 through 19 are going to be using all these hint pages. A bunch of them are going to be kind of using them like different ways. All the solved problems here will be using PEMDAS backwards. Then you'll be simplifying radicals. Alright, so number 11, we have square root 150. 150 is not perfect, but 25 goes into it 6 times, and 25 is perfect. So that 25 turns into 5 because the square root of 25 is 5. 6 stays in the radical forever. That's your final answer. There's not a radical. There's not a... That should just be 11 on the bottom. So number 12. Square root of 18 over square root of 11. First thing we do is take the radical to the top and the bottom to the bottom. Right? Remember, I'm going to multiply by a conjugate. So that's my dotted box. I'm making this up. I'm totally making it up out of thin air. The only rule is it has to equal 1. My choice for my conjugate is I'm going to take the bottom. I'm going to just write it. When it's a simple, easy radical, you just write the same radical. I put radical 11 on the top, because the top and bottom have to match. So multiply across the top, multiply across the bottom, I end up with square root of 198 all over 11. 198 is not perfect, but 9 goes into it 22 times. So my answer for that one is going to be 3 radical 22 all over 11. And that's it for 12. 13, very similar concept. So the first thing we do is multiply by my conjugate. I'm going to put 4 minus radical 5 because that's the special sum one for that bottom. It's the only one that's going to work is 4 minus radical 5. So I copy and paste that on top. The top you're going to distribute. Radical 2 goes to the 4 and the radical 5. So the 4 and the 2 can't be combined because the 4 is not in jail and the radical 2 is. So the top's going to become 4 radical 2 minus radical 10 because 2 and 5 are both in jail. Now, if you don't want to FOIL the top and the bottom, which are the bottoms, you can FOIL them, it's no problem. Or you could take the first number, square it, the second number, radical 5, square it, put a minus in between. Because they're like terms, you can combine them, so your best answer for number 13 is 4 radical 2 minus radical 10 all over 11. That's done because the radicals cannot be broken down, they cannot be combined, and there are no radicals on the bottom. That's it. Alright, 14 is pen was backwards, so I'm going to add 10 to both sides. I'm going to get 7r squared equals 35. I have to divide by 7 before I take the square root, so I get r squared equals 5. Now I can square root both sides. The rule is whenever you square root both sides, plus or minus shows up, so that is your best answer, r plus or minus radical 5. 15 is another Penrose backwards problem. I have 2 times the quantity, x plus 2 squared minus 5 equals 8. So Penrose backwards says you got to get rid of the subtraction first. So if you're not sure what I'm doing, I get rid of the subtraction first, and I do that by addition. So I have 2 times the quantity, x plus 2 squared equals 13. No subtraction. The addition is actually inside the parentheses. There's a division, there's multiplication, so I divide everything by 2. Makes those cancel, so I have x plus 2 equals squared equals 13 over 2. Leave it as a fraction, don't write it as a decimal. Addition is still inside the parentheses, so now I got to get rid of the exponent, so I square root both sides. I get x plus 2 equals plus or minus square root of 13 over square root of 2. Now that the parentheses are finally gone, I can finally just get rid of the minus 2 from both sides. So I have x equals negative 2 plus or minus radical 13 all over radical 2. And that's not a bad answer. If you got that far, I probably wouldn't take off any, I would only take off half point at most. But technically there's a radical on the bottom here, so I'm going to multiply radical 2 over radical 2. So your best answer is going to be x equals negative 2 plus or minus radical 26 all over 2. Best answer. That's it for 15. Alright, 16 we have 6t squared plus 5 equals 2t squared plus 1. So I'm going to put my t squared on the same side. So I'm going to minus 2t squared from both sides. I'm also going to put my 1s on the other side, so I'm going to minus 5 from both sides as well. So put all my t's on the left and all my t squareds on, or all my numbers on the right. So I end up with 4t squared equals negative 4. Now, if I'm doing this backwards, you're going to get rid of the multiplication first. So I'm going to divide both sides by 4. I get t squared equals negative 1. Now, I can square root both sides. So I get t equals plus or minus square root of negative 1, which the square root of negative 1 is just I. So your best answer is t plus or minus I. That's it, 2 answers. 17, very similar concept. I have negative 5 in parentheses, n minus 3 squared equals 10. So first thing I'm going to do, I'm going to divide everything by negative 5, because I'm going to get rid of the multiplication. I have n minus 3 squared equals negative 2. Remember, I still can't get rid of the subtractions inside the parentheses, so I have to square root both sides. So I have n minus 3 equals plus or minus, because that's the rule whenever you square root. The negative right here turns into I, square root of 2. Now I just add 3 to both sides, so my best answer is n equals 3 plus or minus I radical 2. And that's it. Alright, 18, I have 8 minus 5i minus the quantity negative 11 plus 4i. So the negative distributes, so it turns into plus 11 minus 4i. I combine my like terms. 8 with 11 is 19. Negative 5i plus, or I'm sorry, minus 4i is minus 9i. And I'm done. That's it. 19, very similar to the conjugates on number 13. So I have negative 1 minus 6i all over 5 plus 9i. Because it's complex and it looks hard, my conjugate box is going to look like this. So I'm going to multiply. Remember, I care about the bottom, and the bottom has a special someone. 5 minus 9i. I don't care about the top. I copy and paste whatever I wrote on the bottom because this box has to equal 1. So now, I have negative 1 minus 6i next to 5 minus 9i. I'm going to FOIL that. On the bottom, I have 5 plus 9i next to 5 minus 9i. You can FOIL that. I'm actually going to take a shortcut I've written on the hint page. So I FOIL. Negative 1 goes to 5, going to give me negative 5. Negative 1 goes to negative 9, it's going to be plus 9i. Negative 6i plus times 5 is going to be minus 30i. And then negative 6i times negative I is going to be plus 54i squared. Now if you remember from your hint page, I squared equals negative 1. So I squared turns out 54 into negative 54. Now I have to combine like terms on top. So, and the bottom, I'm just going to take 5 squared, I'm going to take 9 squared, and I'm going to add them together. That's just a shortcut. So the top turns into negative 5 minus 54 is going to be negative 59. 9i minus 30i is going to be minus 21i all over 106. I'll take it as a full credit answer, or you could actually split it up, which is probably the best way to do it, but I'm not that picky with this one. Alright, so the complete square you can do for numbers 20, 21, and 22. You can also do quadratic formula for those ones, and you have to do quadratic formula for 23. 24 and 25, you're going to use graphing polynomials. So that's it. So for number 20, you could say A is 1, B is negative 2, C is 25, and you could plug it into the quadratic formula. I'm actually going to complete the square. So what I'm going to do first is that, since it's equal to 0, 25 is perfect, 5 and 5, but it's not the right perfect to give me negative 2, so I don't want 25. So I'm going to subtract 25 from both sides. So I have x squared minus 2x equals negative 25. Now, I'm going to do c equals b over 2, so negative 2 over 2 squared. That's just the rule from completing the square. So c equals 1 squared, negative 1 squared, which is 1. So I'm going to add 1 to both sides. So the left is a perfect square trinomial. It turns into x minus 1, x minus 1, which means it can be written as x minus 1 squared. Remember, it's equal to negative 24. Now I can use penance backwards to solve, so I'm going to square root both sides. I have x minus 1 equals plus or minus, because that's the rule whenever you square root. The negative turns into I. 24 is not perfect, but 4 times 6 is. 4 turns into 2. 6 stays in jail forever. Now I can add 1 to both sides, so my best answer is 1 plus or minus 2i radical 6. And that's it for 20. Alright, number 21, we have 3x squared plus 42x equals negative 24. If you're going to use completing the square, divide everything by 3. So then I'm going to end up with x squared plus 14x equals negative 8. You can do the same thing. If you want to use quadratic formula, you're going to make it equal to 0. Find a, b, and c, and plug in the quadratic formula. I think it's a little bit faster to do the complete square. I'm just better at it. So I'm going to say c equals to 14 all over 2 squared, which is 7 squared, which is 49. I'm going to add that 49 to both sides because that's the rule. That makes the left side a perfect square trinomial. So the left side is going to turn into x plus 7. X plus 7 is going to equal positive 41. Now remember, x plus 7, when they match, can be written as x plus 7 squared, which means I'm now able to use penance backwards. So I square root both sides. I end up with x plus 7 equals plus or minus the square root of 41. Now I can subtract 7 from both sides, I get negative 7 plus or minus the square root of 41. And that is it for 21. 22 is x squared minus 16x plus 7. Once again, if you want to say a is 1, b is negative 16, c is 7, and plug in the quadratic formula, you can. I want to use complete the square. It means I have to get rid of this minus 7 because it does not help me with this problem. So I have x squared minus 16x equals negative 7 because it wasn't perfect. That means I'm going to make a perfect number that I'm going to use. C is equal to negative 16 all over 2 squared, which is negative 8 squared, which is 64. So I'm going to add 64 here and here. So now I'm going to have x minus 4 minus 8 squared equals 57. Square root both sides. I end up with x minus 8 equals plus or minus square root of 57. Add 8 to both sides, I get 8 plus or minus square root of 57. So guys, you could use quadratic formula for any of those. Quadratic formula is a little bit easier to set up. You just get messier radicals that are harder to simplify. Versus complete square is a little bit harder to do. But at the end, you get a little bit easier radicals to solve, to simplify. So that's it. Alright, so because the negative 3n, I have to, I'm more than likely going to have to, and not everything is divisible by 3 right now. Before I do anything, I'm going to make it, put everything together. So I'm going to minus 2 from both sides. I'm going to add n to both sides. And I'm going to put it in the right order. So I'm going to have negative 3n squared first, plus 10n, plus 2 equals 0. So since it is not divisible by a number, and that first number is negative 3, I cannot use completing the square. It's just not going to work. So the only thing I do is say a is negative 3, b is 10, c is 2. I'm plugging the quadratic formula. So say x equals the opposite of b, so it's negative 10, plus or minus the square root of 10 squared minus 4 times negative 3 times 2 all over 2 times negative 3. So I'm going to end up with x equals negative 10 plus or minus. Inside the parentheses, I put all that in my calculator, not the radical. I end up with 124 all over negative 6. 124 is not perfect, but it's 4 times 31. So I'm with x equals negative 10 plus or minus 2 radical 31, because this 4 turned into this 2 right here, all over negative 6. Last thing I do is like simplifying fractions. Negative 10 over negative 6 can be simplified. 2 over negative 6 can be simplified because all three of them have a 2 in common. So the best answer is 5 plus or minus radical 31 all over 6. That's the best answer for 23. Remember, that's x equals. Alright, so 24, the first thing we have to do is we have to find the degree, which is 3. And I care if it's odd or even. The leading coefficient is negative 1, and I care if that's negative. That tells me something really important called the end behavior. The end behavior means it's going to go up and to the left, down to the right. So I'm going to make an XY chart. I'm just going to start with negative 2, negative 1, 0, 1, and 2. Now I purposely leave a little space because in case I got to add some numbers. So I'm just going to plug my numbers in. So I plug negative 2 in for x. So I get negative 8, or negative 8, so it's positive 8, plus or minus plus 4, minus 6, minus 3. So I have 8 plus 4, which is 12, minus 9, so that's going to be 3. Negative 1, I do the same thing, so I get positive 1, plus 1, minus 3, minus 3. So I get 2 minus 6 is going to be negative 4. 0 is going to give me negative 3. 1 is going to give me negative 1, plus 1, plus 3, minus 3. So I'm going to get 0. 2 is going to give me 2 to the third is 8, so it's negative 8 plus 4 plus 6 minus 3. So I get negative 8 plus 10, that's going to be negative, that's going to be positive 2 minus 3 is going to be negative 1. So now I plot my points. I go negative 2 up to 3, put a dot. Negative 1 down to negative 4, put a dot. 0, negative 3, put a dot. 1, 0, put a dot. 2, negative 1, put a dot. So now I connect my dots. We're smooth curves. And it feels like the graph wants to go that way, and that matches my end behavior. So that's it. That one's good. 25, exact same concept, so the degree is 4, which is even. The leading coefficient is 1, which is positive, which tells me the end behavior is going to go up and to the left, up and to the right. So now I make an XY chart. Put negative 2, negative 1, 0, 1, and 2. That's why graphing polynomials is a little bit easier than graphing quadratic functions, because you don't got to think that as much. Sometimes the numbers show up that are a little bit harder. Beyond that, it's a little bit easier. Like 0, I already know is 4, because whenever I plug in 0, I only get the number that's left over. There is no rainbow effect, so you actually have to plug them all in. So I put negative 2 to the 4th minus negative 2 cubed minus 4 times negative 2 squared plus 4. So I get positive 16 plus 8 minus 16 plus 4. So I get 12. Plug in negative 1. So negative 1 gives me 1 plus 1 minus 4 plus 4. So I end up with 2. Now I plug in 1. I get 1 minus 1 minus 4 plus 4. So I go 0. I plug in 2. So I get 2 to the 4th, which is 16 minus 8 minus 16 plus 4, I get negative 4. So there's graph my points. I'm not going to worry about negative 2 because it doesn't fit my window. So I'm going to go left 1 up to 2, put it dot, 0, 4, dot, 1, 0, dot, 2, negative 4, dot. So although I didn't graph negative 2, I do know that it's going to go up towards negative 12, which is all right there. So I know it's going to go that way. Now I start connecting my dots, and it feels like to me like the bottom after 2 is going to keep on going bottom right, which is different than my end behavior. So I'm going to actually pick another point. So I'm going to plug 3 in. So I'm going to pick 3 just to see what happens afterwards. So I plug in 3. I get 3 to the 4th, which is 81, minus 3 cubed, which is 27, minus 36, plus 4. So I notice that my number is going to be 81 minus 59, which is 22. And 22 goes up. So what I find out is that although it doesn't look like it at first, my graph does match what I wanted to. And that's it.